Does phase rotation affect transformer vector diagrams? And it's irrespective of the phase rotation, and it's completely dependent on the winding configuration. Okay, so we're going to take a look at this. This is our standard ABC right here, ABC and ABC on the secondary. What we've done here is we've just identified our taps. This is a YD1. Let's add designations for this, okay? So all we're doing is we're saying that our A phase primary coil is right here, and this is A1, which is the positive polarity. This is A2, which is negative polarity, and we've done the same for every single phase on the primary. And the secondary is all lowercase, and the primary is all capital. And then you can see that my A phase coil is on the secondary. It's connected from A to C, which more specifically is A1 to C2. And that means that this tap right here is connected on A1, and there's a jumper that goes all the way to C2. That's all that means. And so let's expand on this and add more to it, right? It's going to get messy a little bit. So now let's take these coils and redefine these over here and add designations for our coils over here, okay? So you have your A1, 2, B1, 2, C1, C2, and just all the way through primary and secondary. And then the next one, what we're going to do is we're just going to add in our actual bushing connections, right? This is going out of the transformer. These are just our bushing connections, which is representative of this right here. You can see it's all connected to the ones of every single one of them. All right. Now that we have that, let's move on to the next one. So now we know that our primary is a Y. So we're just going to jumper all of our twos together. Okay, that's too easy. And then the next one we're going to do is we're going to build our delta on the secondary. And if you look, we've already shown this designation, but let's just actually use the YD1. This, by the way, this diagram came out of the SEL 587 relay manual, so it's not something that I just fudged and made up. All I did was I just added some designations, which we could redefine these as anything we want, as long as we maintain the connection diagram. So if we say that this is A1 right here, A1, does that connect to C2? Well, it says it right here. It does, right? And so A1, does the A1 also connect over to C2? Yes. And then right here, this is A2 connects to B1. Is that true? A2 is right here, and it connects all the way over to B1. That's true also. And then B2 connects to C1. Is that true? B2 connects to C1. And you can see that also down here. C1 and B2, B1 and A2. So nothing, fishy going on here. And then the next thing that we're going to talk about is all we're going to add is arrows for our vector diagram. Okay, and all that means is if this is the A phase arrow, it's right there. B phase arrow for primary and C phase arrow is right there. And so we're just creating arrows. Okay, and we know what the phase rotation is. We know that these phasers are rotating in that direction. It comes A phase first, then B phase and C phase. So we already know what the angles of these arrows should be anyways. And the parallel arrow for A phase, well, this parallel one is right here. And that same parallel winding is this one right here, which means that our A phase coil, if you look at this one right here on the primary, is wrapped around our secondary A phase coil. And that should be connected on the A1 goes to my A bushing, and then my B connection connects the other end of A. Is that true? Well, my B connection does connect to the other end of A. There we go. All right. So you can go through every single phase and verify that, but that's exactly what that's trying to show and represent on this page. So we've taken the last, just re-verify. We didn't change anything. All I did was I just rotated the picture 90 degrees this way and this one 90 degrees that way, and then just redesignated my terminals. These are both an ABC phase rotation. How do we know that our A phase bushing is connected on A phase 1, A1 and C2? Well, this bushing is the same as that bushing. And you can see C2 is right here, and that connects all the way over also to the A phase terminal. And so does A1, which is right here. Okay, so there's A1. So it's the same for every single one of them. You can go around and look at this on here and here, this is B phase. And then on the primary, it's not too special, right? All of them are the twos, A2, B2, C2, all connect to the neutral point. Very easy on the primary. So if you go ahead and you follow this convention, you'll be perfectly fine. You'll notice that this is a YD1 transformer connected ABC, okay? So let's take the exact same thing and let's look at, we have a couple more slides to go through right here. What we have to do is we want to change this to CBA. And what matters is this is now going to be on the primary C, and then B is going to stay the same, and then A is going to change here. This is going to be C, this is going to be this B right here on the secondary is going to be the same. And then in the secondary, the C is going to become A, which means all of our terminal designations. This becomes A1, this becomes A2, this becomes C2, C1, this is A1, A2, C1, and C2, right? And if you don't do that, that is the most common mistake, to think that you're going to get, instead of a YD1, it becomes a YD11, okay? If you make this mistake, that's what's going to happen. And that's not what's happening here, okay? If you're going to physically re-land the cables on CBA instead of ABC, you're not changing the wiring of the transformer, okay? All you're doing is you're just bringing C phase in instead of A phase. So that's what the phase rotation ends up being. So let's go ahead, and now that we have that outlined and explained, let's go on to the next slide real quick. So here we are on the next one. This is a YD1 also, and this is a CBA instead, okay? And so this YD1, what changed? Well, like I said, this is now C phase instead of A like it was before. Now this is A and A instead of C like it was before, okay? So our A's and C's have swapped, same thing on the primary. And if you follow the convention, primary is easy. This is still a Y convention, right? Pretty easy. This is a neutral. However, on the secondary, what happened here? Well, our C phase connection right here is our right here. So I'm just going to mark those the same. So you have C1 that connects to C1. That makes sense. The other one is A2. Is that true? Follow that bushing around, come around. It goes around to A2. Yes, it does. And that matches everything that we've written down right here in the middle of the page, just as a reference, okay? So this is exactly what I meant by it. Even if you do CBA instead of ABC, it's still going to come out as a YD1 because it's completely dependent on the transformer connections and not on the phase rotation. So this is an example right here. So what we didn't do was relabel our transformer bushings, okay? And this is what I'm talking about. That's ABC, and this one right here is ABC also. We didn't redesignate this. And so we're going off the original convention of ABC. And, you know, the primary doesn't change. That doesn't matter because it's just the Y. It's really easy, right? However, what does change is our A and C phasors change position. And since they change position like this, C is now pointing up, which is right here. And A is now pointing down and to the left, which is right here. All right. So what's our terminal connection? Well, our A tap is right here, and that's going to be right there. And it connects obviously to A1, and the other one connects to C2. Okay, that works out exactly. So if you're following the incorrect ABC convention, instead of redesignating this as CBA like you were intending to on this transformer, then you're going to have, what's going to end up being is that you have the primary at 12 o'clock and the secondary is now at 11 o'clock. Okay, this is 12 and 11. So this becomes a YD11. And this is also a CBA. Hopefully this helps someone to understand the vector diagrams, and thank you all.